There we go. All right, pressure changes. So let's look at this reaction. If you look at this reaction, we have PCl3, chlorine gas, PCl5, all in gas phase. All right, we have 2 molecules of gas on the reactant side. All right, and we have 1 molecule of gas on the product side. So if you think about pressure, we could say the reactant has about 2 atmospheres of pressure, because all pressure is the molecules pushing against something. Okay. Whereas on the product side, if it was mostly products, you'd have 1 atmosphere. Okay. So depending on what we do with the pressure of the system, you can shift it to the left or to the right. Okay. If you increase the pressure, okay, do you think the system wants to go towards more gas molecules or fewer gas molecules? If you increase the pressure. Okay, everybody's in this room. Everybody's a molecule in this room. If I shrunk this room down, do we want to stay in this room or do you want to go out through the door? You want to go out through the door. So if you increase the pressure, that's shrinking the volume, right? Because pressure is just how many molecules are hitting each other. So if you shrink it down, you increase the pressure, you're going to shift to the side that has fewer gas molecules. Okay? So we can look at that here. All right? Here's the graph. So we increase the pressure. Now, here's another thing about pressure. An increase, it says it at the bottom of this page. If you reduce the volume, all right, you're increasing the pressure. Okay? I'm just going to write that here at the top. If you decrease the volume, that equals an increase in pressure. Just think of us in a room. If we decrease the volume, the pressure is going to be increased between everybody. All right? What that also does is it changes the concentration. Because what are the units for concentration? Yeah. So concentration, which is moles per liter. I've changed the volume, which means I've changed the liters. So what's happened to the concentration? Has the concentration gone up or down if I decrease the volume? It's gone up. Okay. So therefore, concentration increases. With a decrease in volume. Okay, so we have the system at equilibrium. So everything's happy and fine. We shrink the volume of it. When you shrink the volume, you change the concentrations. Everything will spike. That's how you know it's a change in pressure. Because all the concentrations spike, right? Because we've shrunk the volume. All right? So the spike here is a dead giveaway that you've changed the pressure or the volume. Okay? And since we shrunk it, this reaction doesn't want 2 molecules of gas. It wants to go to the side that has less molecules of gas. So it's going to shift towards the right. Okay, so you get this initial spike, and then PCl3 and Cl2 will both decrease because the reaction is pushing back towards the right, and the PCl5 will increase in volume until it reaches the new equilibrium, which is the flat line. So concentrations to all gas in the container will increase. And then the equilibrium shifts to the right to counteract this. You want to move to the side that has the fewer gas molecules. All right. And I just want to make a note. When all concentrations spike, that equals some sort of pressure or volume change. Because that's a good test question. I can give you a graph. I can draw something like this, and I say, what did you do to the system? All right. And if everything is spiking, it's usually an indication that there's a pressure or a volume change. Okay. And then everything levels out. We reach a new equilibrium once it stabilizes. All right. When you do pressure changes, though, only gases are affected. Okay. When pressure is a stress, only gases or gaseous reactants and products are affected. Volumes of liquids and solids are not. Okay. Only gases. It's the only thing you have to look at. If you don't contain any gases, nothing happens. So that's another good test question. If I say that you do a pressure change to a system that is only solids and liquids, and I say, which way does it shift? You say, there is no shift because it only affects gases in the products and the reactants. If there are equal moles of gases on either side, reactants and products, there's no shift either. Okay? No effect. All right? It only affects gases. So if you have equal numbers of gases, there is nothing happens. You have to have a difference. Okay. So this is sort of a classic quiz/test question. Here's a reaction. NO plus chlorine gas gives the NaCl gas plus 76 kilojoules. If we decrease the concentration of NO, okay? So we take this and we remove it from the system, all right? Which way is the equilibrium going to shift? It's going to shift left to compensate for that, okay? All right, let's sketch the graph of what this would look like. So I don't really care where you put all this stuff, but NO, NaCl, and Cl2. Okay. They're all at equilibrium. So they're all, whoops. So they're all flatlined. Okay. We take out the NL. So what do you see on the graph right away? See a drop right down. So it drops down. Okay, then what? And then it's going to increase, right? If you take it out of the system, the zero concentrations, they drop down, and the equilibrium shifts this way to compensate for that. So then it's going to come back up. If my pen would work. There we go. It shouldn't come back up to the same level, though. So that's not a good representation there. So it increases. And then it levels out. Okay, what does the NaCl do? It's going to decrease. And I should have given myself more space here, but that's okay. It's going to decrease till it levels out. And then what's Cl2 going to do? It's going to go up. And I'm going to have them. I don't know what this reaction's equilibrium is, so I don't know. I'm just going to show it increasing. That's really bad graphing on my part. But all I'm going to look for on a test, if I give you a question like this, is does the Cl2 increase? Does the NOCl go down? And is there an immediate drop in the concentration of NO? Okay. Most likely, I would just give you 4 graphs and say which one represents the stress. All right. If we increase the temperature of this system, so we heat it up under a Bunsen burner like you did on Friday, which way does it go? It's going to go left, right? Because we have energy on this side, so it's going to want to shift back. See if I can do a better drawing here. NO, NOCl, and Cl2. Okay. What happens to NO2? Or NO, sorry. It's going to go up. But is there a spike? No, there is no spike. So they're all flatlined. And then NO increases. NOCl should decrease. And Cl2 should increase. Until they all flatline again and you reach equilibrium. Okay. What if we squish down the volume? So we decrease the volume. If you decrease the volume, what are you doing to the pressure? You're increasing the pressure. So that's an increase in pressure. If you increase in pressure, which side does the equilibrium move to? It's going to go to the side with the lower amount of gas molecules, which in this case is the right. So you're going to get a shift right. And NO, NOCl, Cl2. NO goes down. Whoops, that's not right, is it? What do I have to draw? You have to draw spikes, because if you decrease the concentration, everything spikes in or decrease the volume, concentration spikes. So you're going to get a spike, spike, spike. And then because we're going to the right, NO is going to decrease, NOCl will increase, and Cl2 will decrease. And yes, they should be representative of the moles, but it's kind of hard to draw it when you're just drawing it freehand. And I'm not a good artist. All I care about is you can tell me which way it goes, which way it shifts, and what will increase and what will decrease. And I'm looking for the spikes too. Okay? So which way does it go if you increase the pressure? Side with the least amount of gas molecules. What if you increase the volume? It's going to go to the side with more gas molecules because that's decreasing the pressure. Okay. Finish the rest of those questions, please. I think I got you to do number 1 last time, so the rest. Then we'll do package 2, and then we can talk about the lab because package 2 relates directly to the lab.